Okay, welcome, Sarah and Megan and Maya. Thanks for coming. I like to think of this as now we're moving into the second half of the class because it's really going to change from now. And I think you'll agree. Hopefully you'll like the change. I can't know until it happens, but I like the change because we've been spending the last few weeks kind of coming up with things that could help us. So coming up with things that I promised would be useful for the rest of the quarter. Things like the normal distribution and the central limit theorem and what is a continuous distribution. So now we're actually going to spend the entire rest of the quarter with applications. And that's pretty much all we're doing for the rest of the class. So everything we do from now on is all about applying it. So let me share my screen and let's talk about the plan. Okay, so here is a plan for the day. We'll start out with questions, and if you have any questions about anything, I'll help you out. Then we'll talk about confidence intervals for a mean, for a population mean. Then we'll talk about confidence intervals for the population proportion. That's going to be kind of a theme for most of the rest of the class. Is we're going to be looking at the quantitative question, right? The question has a number answer, and we'll do stuff with it. And then we'll say, but what if it's a yes/no question? And then we'll realize that we can do similar stuff with that. And that's going to be, like I said, pretty much most weeks of the rest of the class. And then we'll look at the sample size needed for a confidence interval, which is very different, it turns out, than the sample size needed to say that you have a normal distribution. So this is more reality. So one thing you could say, yeah, you have a normal distribution, and you did your sample, of 32, but the question is, are you getting good information? It's true that it's normal, but are you going to end up being able to say, yeah, well, the average height of the, of people in America is somewhere between 2 inches tall and 18 feet tall? Because I did my normal distribution and that's what it said. And that's totally worthless to say the average height of Americans is between 2 inches and 18 feet, because we already know that. So more important today is to say, well, what if you want to find the average height, but you want to be accurate within a half an inch? How many people do you need to survey? That's the kind of stuff we're going to be doing today. Instead of, do you have a normal distribution? But it's, are you going to have what's called practical significance? So are you going to have information that is actually going to help people? Okay, even though you sometimes you do everything right and then you have worthless information, not wrong information, but something that no one's going to be able to do anything with because it's too widespread. So we'll talk about the sample size for means, and then we'll go to the other way and we'll talk about the sample size proportions and how many people do you need to survey for the yes/no question. So that is the plan today. So let me ask you, are there any questions about anything? This is the time, the best time.
I was actually wondering when we should get started on project 2.
Okay, that's a really good question. So I'm going to have an answer that you're not expecting, and that is immediately. Now, you probably didn't expect that. But when I say immediately, how did you start on project 1?
Immediately, first day?
Yeah. Day 1, what'd you do?
Pick partners.
Exactly. So project 2, you could start immediately and pick partners. You're allowed to use the same partners.
Okay, that was my next question.
But if either one of your partners is dropped, or if you only had one other person, then it's always better to have 3. Or if you just didn't, you just weren't a group that worked together well, then find other partners. You know what I mean?
Okay.
So immediately as in you could do that. Okay, but it's kind of the same answer that had you asked me the first day class for project 1, is that immediately you're ready to pick partners. Okay, that you can do because you don't know anything about project 2 to pick partners other than you need partners just like project 1. On the other hand, you're not ready mathematically. Really, probably maybe next week, if you really want to get started early. If not, definitely the week after. So it turns out project 2 is all about chapter 10. Okay, project 2 is all about chapter 10. We're in chapter 8 right now. And I think, I don't know if I've mentioned this, but every week is a new chapter. We don't do 2 chapters in a week anymore. So I have a couple reasons why I do 2 chapters towards the beginning. One is I really do think some of the chapters are kind of shorter. And the other is a little reality, and that is other classes tend to be hard at the end and easy at the beginning. That's what I've found. Like your big English paper is typically due towards the end of the quarter. And so I kind of lighten up a little bit in the last half compared to the first half. So I should let you know that. Doesn't mean the class is easy, but we don't have as much material each week. Okay, so we only do 1 chapter a week. And again, we are in chapter 8 right now, which is confidence intervals for a single population mean and proportion. Okay, that was a really good question because I was going to say it anyway. So perfect. Other questions? Other questions? Okay, if there's no other questions, then I have a question for you. Okay, and this is, you may not feel comfortable answering it. And the rule is you don't have to tell the truth, but you have to give me something that is believable. So that's all I ask for. And if you put it in the chat box, and remember the chat box is not recorded. So the only ones that can see the answer are you and, you as in the 7 of us here. But everyone needs to have an answer because they're not enough. Uh-oh, I think I just scared someone away. Now there's only 6. What happened? Yeah, it's not that hard a question. It's not bad a question. But I'll mention something because I've been doing the same question this is my 25th year of doing it. And here's the question. So how old were you when you experienced your first passionate kiss? Okay. Oops. So that's my question for you. And again, you don't have to tell the truth, but it probably doesn't hurt to tell the truth. I'll put mine in too. Okay, and everyone has to put one in. Again, if you don't feel comfortable putting how old you were, make something up. Don't say 875 years old, please. So it has to be at least a believable number, but we just need numbers. We need data. Okay. So let me type in the numbers I'm looking at. We have a 14, a 19. We have a 14, a 13, a 22. A 16. Okay. And that's all of us, I think. Yeah, because we lost our 7th person. Not sure what happened. But we'll do it. We're going to have a tiny sample size, but that's all we can do. Okay. So when I ask data from you guys, we're not going to get a big sample size. I do want to let you know, in the real world, it would never, ever do anything with a sample size of 6 and think that you have good data. So that's just a big disclaimer here. I'm only using a sample size of 6 because that's all we've got. Okay. The other interesting thing Do you think compared to, all the people in my school and stuff, do you think I was old or young when I had my first kiss?
Young?
Okay. I didn't know anyone that hadn't already kissed someone when I kissed my first girl. Okay. So I'll let you know something. I've been doing this for 25 years. Things have changed. People have changed. Okay. I'm old. And that's what's up. My generation is different than your generation. And it's clear, not just because I've been doing it, I've also read other people's research. And just let you know, it has changed. It's kind of cool. So statistically, I can tell you for a fact that the age has gone up and up and up. Okay. I have a feeling if I'm still teaching in 15 years, everyone's going to say over 20, no matter what. I don't know. Okay. So that's just a note. It's kind of a aside. So now the question I have is, we can easily, and this isn't a question, but we can take these numbers. I'm going to copy them. I'm going to go to the calculator. And I'm going to go to the one variable statistics calculator. There's a sample, right? I'm not even sure what the population would be. People that are involved in statistics classes, because I'm not a student. So people involved, I'm involved in at least. And then I'm going to hit calculate. And I get a mean of about 16.33333. So let's write this down. So our mean, by the way, what symbol do I use for this mean? Very important. We talked about symbols last week, but it's real important to get these symbols down. So remember, this is 6 out of all of the people who are involved in statistics classes.
The bar?
Yeah, the bar, X bar, X bar.
X bar. Oh,
Yeah.
bar.
But I'll go for bar. Okay. Not that I go to bars, but So X bar again was 16 and a third. I'll just throw some 3s in. No one really cares about 6 decimal places, but I just put them in. Okay, and then we know the standard deviation. What symbol do I use for the standard deviation? 3.5024. Hint is it's easy to type. What symbol represents a standard deviation?
Sigma?
Okay, remember this is 6 out of the big population of everyone involved in statistics. So sigma would be the standard deviation of everybody involved in statistics, but we just have 6 of us we're looking at. So do you remember what you use when you only have a sample? So sigma's important. That's for the population standard deviation. What about the sample? The hint is it's very easy to type. No one remembers? S. So it's letter S for standard deviation. 3.5024. Any questions on that? Okay. So now comes a harder question. I'm pretty sure that the population mean age of first kiss for everyone involved in statistics, let's say in California, is not exactly 16.33333. Okay. I doubt it's exactly that. My data is not that trustworthy. I only have a sample size of 6. So how trustworthy do you think it is? Do you think it might be that the average age is 28 after looking at our data? What do you think? Do you think you can kind of rule out the average age of being 28? Yeah, it shouldn't be 28 because if the standard deviation is around 3.5, even if it was 4, if we were off by a little bit, and the average was 28, that's way too many standard deviations below the mean. Does that make sense? So it shouldn't be 28. How about 5 years old? Do you think it could be that?
No.
No, shouldn't be that either. Way too many standard deviations below the mean. Does that make sense? Do you think it could be 17 years old?
Yes.
Okay, that could be. Do you think it could be 15 years old?
Yes.
All right, so now comes a hard question. Okay, we said yes to 17, we said yes to 15, we said no to 28, we said no to 5. So what boundary would you put so you think that it's likely in this interval, but unlikely outside of it? Any questions on the question? Okay, and I don't expect you to tell me the boundary because you don't know how to do that yet. But do you understand what the goal is? So our goal is to say we have a sample, and we have our sample mean, and because of the central limit theorem, the sample mean is the best guess or the best estimate for the population mean, but you're probably not exactly right. You might be off either too high or too low by a bit. Any questions on that? So the big question is, what is that bit? So I have a picture that we're all familiar with. At least I hope you're familiar. Are you familiar with the shape of this curve? You better be. Right? In one word, what's the shape of this curve?
Bell.
Yeah, bell, but remember in our class, what do we use? Normal. Yeah, normal. So use the word normal, not bell in our class, okay? Okay, so we use the word normal distribution, okay? By the way, in case you're like bell, and I'm being mean because I'm using normal, which sounds harder, there's actually another name for it that's even harder, and that's called Gaussian, named after the guy who figured this stuff out, a guy named Gauss. But we're going to be calling it a normal curve or normal distribution. And we have X bar, which is our best guess. So I'm going to put X bar right in the middle of that curve because that's our best guess, right? And what we want to do is want to say, well, how far out can we go left and right so that the probability of being inside this area is a high probability? Any questions on that idea? That probability is called the confidence level. And for short, it's written CL, confidence level. Any questions so far? How far you need to go left and right so that you have that probability is called the margin of error. Have you heard those words before? Not necessarily in our class, but have you just heard margin of error? Just offhand in news or something like that? Any articles? Okay, maybe you haven't, but now you have, and it's important. And I am using the letter E for margin of error. Okay. I want to let you know that the original textbook didn't use E. They used awful letters. It was so damn confusing. So do you know what I did? Any guess? I changed the book. And I'm not sure if you understand the kind of book we're using. It's called Open Educational Resource, which means that the copyright is I can do anything I want with it. And I made it easier and I called it E for error. It used to be really miserable. You had all these different sets of letters depending on what you're looking at, and it was awful. But I want to let you know, if you look at other textbooks, including the original OpenStax book, it was just confusing as you can be. So I simplified it, and now it's starting to catch on. I think the whole country is going my way. So I'm using E for error. Any questions on that so far? Okay, now it turns out that the standard percent, or the standard area here, or the probability of being right is another way of saying it, is 95%. That's standard. And when I say standard, all social science uses it. Okay, so whenever social science is going to be doing one of these intervals called a confidence interval, they're going to use 95% for the area that's shaded in here. Okay, that does not mean everyone in the world uses 95%. In fact, when I did some consulting work for the Forest Service up here in Tahoe, they wanted 90%. And the motto, the boss is always right. So I said, sure, we'll do 90%. And we did 90% because that's what their standard was. But in terms of social science, standard is 95%. Any questions on that so far? Okay, if you go to 99%, because if you want to be even more sure, what's the cost of that? Wouldn't you rather be more sure and do 99% instead of 90? 95? What's the cost of moving up to being 99% confident? From this picture. Anyone see it? So if this is 99, if this is 95%, and we need to go to 99, where are we going to have to push these bars?
Further out, more towards the edge.
Yeah, you're going to have to push the bars more towards the end. And the problem with that is that makes E, or the error, larger. Okay, so it's kind of like saying, well, we could be like 99% confident that the age of first kiss is somewhere between 8 years old and 28 years old, but that, or maybe it's say 8 years old and 21 years old, but that doesn't really give you any information that you didn't already know. Of course, it's between 8 years old and 21 years old for average age. Do you see that? And yeah, you're 99%, you're very confident, but you haven't learned anything. On the other hand, if you went to 90%, that might be between, say, 15 and 17 years old. And that's a nice range that you got some new good information about. But being 90% confident, now you only have a 90% chance of being right. And you have a 10% chance of being wrong. And it sucks to be wrong. So do you see the trade-off? If you want a higher percent chance of being right, then you're going to have a wider spread in your numbers. If you are okay with a lower percent chance of being right, then that means your spread is lower. Your error is going to be smaller too. Any questions on that? So you have to give one thing to get the other. Okay, now if we really wanted a better idea, what would we do? If we wanted both, we wanted everything. We wanted to be very confident, and we wanted to have the spread be very small. What's the only way to do that? Any thoughts? The hint is it's a lot of work. Okay, I don't see y'all jumping in. So if you think about the central limit theorem, the way you do that, if you want this curve to change and to get more squished towards the center, we need the standard deviation to be smaller, don't we? And from the central limit theorem, the way you make your standard error smaller is a bigger sample size. And our sample size was 6, which I already told you is terrible. You want bigger than 6 if you can. Does that make some sense? So this is the picture. This is a picture of confidence intervals. The confidence interval goes from this x minus e, or x bar minus e, to x bar plus e. Okay. Any questions so far? There is a problem. And the problem is that in order to even get this curve, you have to know the mean and the standard deviation. And in particular, you have to know the standard deviation of the population. And you don't. We don't know. We really don't know the standard deviation of the population of all Americans, right? Call it maybe American who have experienced a KISS already. Okay. Okay. Or actually, sorry, all involved statistics people is what our population was. We don't know that. We only know our 6 people, which means that our calculations are going to be off by a bit. Does that make sense? Because what we're going to be able to do, what we're going to have to do is we're going to use our best guess for the standard deviation, okay, or the standard error, which is going to be the standard error for our sample size of 6. And that best guess is a little bit off. And believe it or not, this was all figured out through beer. That's what you're all thinking, right? Anyone know why? What does that have to do with beer? And I don't expect any of you to know. Okay, the guy who figured this out was a statistician working for a beer company. And he was trying to figure out the best beer for the company. And he realized that the numbers didn't work. And he came up with the idea, the reason is that he was using the sample standard deviation, which wasn't exactly the population standard deviation. And he came up with the following. What he found out was that, sigma sub x bar is sigma over root n. That happened last week. And the problem is we don't know sigma, so you have to use S. So that's got a little error. And he realized that there was a kind of an adjusted distribution from the normal distribution that kind of took in that error. And he was also a teacher. He did both. And he named it after his students. And he called it the students' t-distribution. So that's the name of the distribution we're going to be using to come up with our confidence interval for a population mean. Is we're going to be using not the normal distribution, we're going to use the students' t-distribution. Okay, and if you just looked at it, it would look pretty normal. You probably wouldn't be able to tell the difference, but it's slightly off. The sample size is 6, it's a little more off. It's a little more spread out. Okay, and the mathematics is very complicated, so I'm not doing it. Sound fair? Okay, you can always come to my office hours and bring Kleenex because you'll be crying. That's really brutal. Okay, it's way too hard even for my 6th quarter calculus students. It is brutal. But do you know what brutal means for you guys? If the math is brutal? Yeah, calculator. Trust the calculator. It does it. Trust me. I'm the one that made the calculator, and it works. And I've tested a lot, so I know it's working. Any questions so far? Okay, so let's do our example. So the example is find a 95% confidence interval for the age of first kiss. among people, or let's say adults, involved in stats classes. Any questions on the question? Okay, so what that means from this picture is we need to find this x bar minus e and x bar plus e. Okay, not quite a normal distribution in a t distribution, but it'll look similar. So we need to find out this bottom number and we need to find out this top number so that the area in between is 95% or 0.95. Any questions on this idea? Okay, are you seeing why we needed last week's stuff to understand what we're doing now? Okay, otherwise I'd show you this picture and you didn't know what it would have meant. Okay, and again, this is for the sampling distribution, not the population distribution. It's a sampling distribution. So now what I can do, and what I'm going to do is skip the very brutal mathematics. Trust me, you want it skipped. Is I can go to my calculator. So I'm going to go back to the calculator menu. And what do you think we want? And the idea is I tried to make this pretty much in order. So where are we? And let's pretend all we had was the 6 values. So you told me we got our 6 data values, and now we want to figure out what calculator to use.
10, confidence interval for the mean with data.
Number 10. So use number 9 if you're given the mean and the standard deviation, which we kind of know because I did the calculation, but you don't need to do the calculation first. If you just have the data, click number 10. Again, I tried to make it pretty easy. So in the data, type in the values separated by commas. I copied and pasted. CL, what's CL? So what is CL?
Confidence
Control limit.
I'm looking for a number.
0.95.
0.95, because I want a 95% confidence level. So 0.95. Okay, and I decided to have you put in a decimal instead of a whole number. And it does say, for example, for a 95% confidence level, enter 0.95. That's the most common. That's why I use that as an example. Okay, but you should always read the question. Sometimes the question will ask you for 90% or 99%. You can do any percent you want. Okay, and then hit calculate. Notice the X bar and S, that's just given. So this does it anyway. I didn't even have to go to the other calculator before. I could have gone right to this one. But more importantly, we have a lower bound and an upper bound. And the lower bound, I'm going to round in the nearest maybe decimal place, 1 decimal, because nobody really cares about 2 decimal places for the mean age of first kiss. I know you care on that day that, you know, today versus tomorrow to have that first kiss is a big deal. But later on in life, you don't really care whether it was, you know, whether you was 16.1 or 16.13 years old. So let's go. But 16 and 16.4 might make a difference, right? A half a year or close to half a year might make a difference to you. Okay, so I'm going to go 1 decimal. And the lower bound is 12.7. Upper bound is 20. Any questions on that? So let's go back. So our confidence interval is 12.7, comma 20. Any questions so far? Okay, the error, by the way, I'm going to write down the whole words. Margin of error, and that comes up a lot in like literature, articles and any kind of publications, they often state the margin of error. So the margin of error, what you can do is you can subtract these two numbers and divide by 2. So 20 minus 12.7 divided by 2. 20 minus 12.7 is 7.3. 7.3 divided by 2 is, let's see, 3.65. Okay, so 3.65. And often you will see a plus or minus. It basically says on either side. Because it could be on the left, it could be on the right that you might be off. Any questions on that? Any questions? And by the way, the letter that we use for that is E. E for error. All right, so now the next thing to do is to...
How do you interpret that error? So is that like 3%, 3 numbers, or?
Actually, remember, because this is age of first kiss, right?
Mhm.
So our, let me remind you, let's go back here. Our X bar was about 16.3. So let me write that down. So our X bar takes a minute to make the bar happen, was equal to 16.3. So X bar is our like best guess, right?
Mhm.
And then we're going to say that in terms of our own comfort zone, we might be off by 3.65 from 16.3. And that's why the plus or minus, because if you take 16.3 and you add 3.65, you basically get your 20. And if you subtract, you get your basically 12.7.
Okay, got it. Thank you.
Yeah, so that's the margin of error. It's how much you are comfortable being off by. Does that make sense? So there's a 95% chance that you won't be off by more than that amount from your best guess of 16.3. Does that make sense? Okay, so now let's write down in a sentence the confidence interval. Make it a little bigger. So interpret this confidence interval. Okay, and here's what we say. With 95% confidence, the population mean age of first kiss. We're talking about for all people involved in stats classes. That's our population. Is between 12.7 years old and 20 years old. I want to do the following though. I want to put word population in red, bold. What do you think it means if I'm putting it in red and bold? When was the last time I put some words in red and bold in a sentence? It's been a few weeks. 3, I think, actually.
We need to remember it,
Yeah, but in particular,
use it in our language when we're talking about.
yep. And
input.
on exam 2, what do you think will happen if you don't put the word population in there?
We'll get points deducted.
You will get points deducted, and that's a promise. And what do you think will happen if you do put the word population mean in?
We'll get the point.
You'll get the points. And you probably want points, right? So put that in your notes. That needs to be there, okay? When we're doing a confidence interval, okay? And I know I'm getting ahead of myself, but next week's stuff, you're gonna have to have the word population also. Just kind of keep that in the back of your head, and next week we'll get to it and you'll see you have to have that too. But for this week, when you're doing a confidence interval, it's all about the population mean. It's not about the sample. It's not about the 6 people that we looked at. It's about all people, the whole population of all people who are involved in stats classes. Okay. And maybe I'm gonna change people to adults. Your kids don't count. Especially if you have a little baby. They better not have had a passionate kiss. Okay, any questions on this? I'm also going to put in with 95% confidence. It won't always be 95%. Sometimes it'll be 90%. Okay, but the idea is whenever I ask you to interpret the confidence interval, your answer should always start with the word with. Any questions on that? And I'm not sure what I need to do to convince you of this about getting points versus not getting points, but I will let you know. You know, the words, remember, many, average, likely, and close to? Do you remember those words? And do you remember me saying that you would lose points if you didn't put them in? I don't know what happened. Half the class didn't put them in. I don't know what to do to get you to put these words in. So this word population needs to be there. I'm going to say it over and over again because it has to be there, because otherwise you're not really talking about the confidence interval. Any questions on that? Okay, the word kiss will not usually be in a confidence interval because there's confidence interval for all kinds of things, but population will always be in it for the mean. All right, so next, what does it mean to be 95% confident? So that's different than saying interpret the confidence interval. What does it mean? Well, 95% is a probability. I'm going to scroll up a bit again because it is this area under the curve that's shaded in is 0.95. Now, a probability means of all the different things that could happen, that the number that are going to work divided by all the total should be 0.95, because that's what probability is. It's a division thing. Okay, well, the things that could happen when we're talking about the central limit theorem and all of the sampling distribution stuff, because this is a curve of the sampling distribution, this is all the different X bars that could happen. Okay. So that's kind of what we're looking at, but I'm going to change it slightly. So let me write down what does it mean? And here's what it means. So it means that if we sampled many groups of 6 people, and actually instead of people, adults involved in stats classes. Okay, so we just did a group of 6. Well, I could ask a different group of 6. I could have found different stats students. Could have gone over to, I don't know, Los Angeles City College. asked 6 stat students in that group. I could have gone over to Wyoming and asked those stats people. I could do all kinds of groups of 6. Every time I do a group of 6 students, I could put it into my calculator. And each time I'll get a confidence interval from that group of 6. Do you believe that? For any set of 6 numbers, I can get a confidence interval. Okay, and they'll be different depending where I go. So let's continue writing. Then each of these will result in a different confidence interval. Any questions on that so far? So the idea here is that 95% of these intervals will contain the true population mean age of first kiss. Okay, now I like to think about where we have this confidence interval. We've just got it, and it was 12.7 and 20. And if the true population mean is between there, then we have a good confidence interval. It worked. Does that make sense? But if we got unlucky and the true population mean age of first kiss was not in that interval, then it sucks. We blew it. Right? We're going to report this out. We're going to publish it. And we were wrong. And that sucks, doesn't it? So the percent confidence is the probability of being right, which is the probability of having that true population mean age of first kiss in our confidence interval. Okay, and what that means is that of all the different confidence intervals that could be created from sample size of 6, 95% will be successful and have the true mean, population mean, and 5% we blew it and we're unsuccessful. Any questions at all about what a confidence interval does? Okay, do you think you'd ever want a 10% confidence interval?
No.
No, you don't want to be wrong 90% of the time. Okay, so 10% confidence interval just never happens. 95% is the most common, but you might want a 99%. When might you want a 99%? Think in health. That's a hint. Think in the medical field.
Like in the development of vaccines.
Yeah, so for development of vaccines, okay, you don't want to be off by much, because if you're off by a lot, you're going to end up killing people, or you could end up killing people, which would be awful. Okay, so in the development of vaccines, you might not want 95% confidence. You might want 99%. Do you see that? You don't want to be wrong. Any questions on that? So if people are going to die because you're wrong, then you're going to want 99%. And then if you still want a small margin of error, then you sample a lot of people. Okay. By the way, for the Pfizer Moderna, do you know how many were sampled?
34,000.
Yeah. 34,000 people. Now, that's a pretty big sample size. That's bigger than we've ever talked about. The reason is they wanted to make sure their confidence interval had a very small margin of error with a high confidence. Okay. And you've probably heard You know, how effective is Moderna, for example? Have you heard that percent? You haven't heard it?
I think it's
So if
like
you've been-
95,
Huh?
95%.
Actually 94%.
Yeah.
So about 94%, a little more than 94%, about 94% effective. But they only did a sample, especially when they first did it. And what's the margin of error? Do you think it'd be okay to have a margin of error that is 30%? No, that'd be horrible. Do you agree? So that's why they did such a big sample size, is they were able to say with 99% confidence that the effective rate of the vaccine is between like 94.3 and 94.6%. Okay, which means they know what's going on. Is that clear? Okay, so when you have something like a vaccine, you want more than a 95% confidence. You want a high level of confidence, and you want to make sure that you have a low margin of error. And the only way to do that is a big sample size. Never sticks, by the way. Any questions on this? Okay, so let's continue on. And I wrote some templates because I think it's helpful. Okay. I don't recommend just memorizing a template and having no idea what it means. Make sure you understand what it means also. But the template will help you in writing. So the conclusion template is with whatever percent confidence. So XXX, by the way, please do not write XXX in your, on exams or discussion post answers. Please don't use XXX. This is just to let XXX just means you're going to put something else in. So with whatever confidence, it can be concluded that the population mean blank, 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 so ours was age of first kiss, is between blank, 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 and blank, blank, blank. Any questions on that template? Okay. And then interpreting the confidence interval level template. So now level, not interval, that's important to note, is if many samples of blank, blank, blank are taken. So in our example, it was six adult students involved in statistics classes, then each would produce its own confidence interval. Blank, blank, blank percent, in our example, was 95%. Of these confidence intervals will contain the true population mean, blank, blank, blank. So that would be mean age of first kiss. And whatever percent. So that if we had 95% contains it, then 5% won't contain the true population mean. I'm not sure if that's helpful. I don't want to confuse you either, but I think a lot of people like to have a template. Any questions on the template? Okay. Big note, if the a sample size over 30 is still required if we do not know the population distribution. If we do not know the population distribution, I guess I should say it's normal. So in other words, if we don't know a normality, like our sample size of 6, we should not have done this confidence interval. I just did it because then we can have an example. Okay, so this is for means. Any questions about confidence intervals for a population mean? Okay, so again, means are when the survey question is quantitative, like how old were you when you experienced your first passionate kiss? Because your answer was a number. I was 13. Okay, I didn't say yes, I said 13. Does that make sense? Okay, always look at the survey question and what all the different people are going to answer to the survey question and what the data is going to look like. And if those are numbers, it's quantitative, and then we do what we just did. I do want to let you know this is not for comparison studies. So this is not okay if you wanted to say compare, I don't know, maybe Caucasians with non-Caucasians. You can't do that with what we're doing in this chapter. But I will let you know you will be able to in chapter 10. And that'll be what your project is about, is you'll be doing a comparison study for your project. Okay, and you're gonna be doing confidence intervals and some more stuff too that we'll talk about next week. So that's just a note, a heads up. Okay, now let's talk about proportions. So here's the question I've got. What percent of Americans approve of the job Biden is doing? Does anybody know the exact percent? Does anyone know the exact percent of the job Biden is doing?
No.
No, nobody knows. Because in order to know the exact percent, you would have to survey everybody in America, right? And by the time you're done surveying everybody in America, Biden won't be alive. I won't be alive. It would take, 100 years. You wouldn't be alive probably. So, maybe you'll live to however 100 plus whatever years, but you can't do it. But what we can do is we can get a confidence interval. We can say we're never going to know exactly the percent, but we can get a good guess of the percent and say we're off by about this amount, or we could say that it's between this percent and the next percent. That we can do actually. So in particular, I have a link. And I said we can do it, but we didn't. Yahoo did it, okay? Or actually AP Norc did it, but Yahoo wrote about it. So I read about this today. So this is at least was a brand new article. And that's what I like about this class is that I can pretty easily find things today in today's news and bring it right into the class. Whereas I can't do that for, say, an algebra class. Good luck. Okay, but I'll be able to do that for every week now without any issue. Okay, so President Biden is plunging into the next phase of his administration. Okay, with a steady approval of a majority of Americans, according to a new poll by the Associated Press. Okay, so let's look. Biden's overall approval rate sits at 63%. I'm going to copy that. Okay, does that mean that we know that exactly 63% of all Americans approve of the job Biden's doing?
No.
No, we don't know that. Okay, because again, there's no way they asked everyone. The only way you can know exactly is if they asked everyone. I know they didn't. How do I know they didn't?
Because it would take forever.
Now, how do I know for sure they didn't?
They didn't ask you.
Exactly. Did any of you get asked?
Nope.
No.
By the way, I've been teaching this for 25 years. I've never had anyone say yes to any example I've given. Did you get asked? So that's never happened. Okay, we'd have a big country though. Okay, so none of you got asked. Okay, so let's find out, who did they ask? So I'm going to scroll a bit. I think it was towards the end. I remembered I saw it. I saw it somewhere. Don't tell me they changed it after I looked. Maybe I have to go story continues. It's usually at the bottom. But we need to know. I know I saw it. Don't tell me they got rid of it. I think I remember the number, even if they got rid of it. Okay, well, I'm going to say, at least my best memory of it, is suppose they asked or they surveyed 916 Americans. Okay. So now come up with a 95% confidence interval. For the population proportion. Any questions on the question? Okay, so my first question I have for you, was the sample size large enough to even do this?
Yes.
And how do you know?
It's greater than 30.
Okay, so beware. Okay, I'm glad you said that, so I can tell everyone to be careful and don't say that. This is a proportions question, yes, no question. 30 is not the number with yes, no questions. What's the number with yes, no questions?
5.
5. So be very careful on an exam, you'll lose points. Don't make that mistake. So yes, no questions is not about 30. It's about 5. But it's not the sample size being 5. Do you remember what has to be bigger than 5? NP. Okay, NP and NQ. Well, in this case, NP is equal to 916 times 0.63. And I don't even need a calculator. I know that's bigger than 5. We're talking about more than half of 916 is more than 5. And NQ, which is equal to 916 times 1 minus 0.63. And that again, that's, 37% of 916. 37% of 100 is 37. So 37% of 916 is much bigger than 5. So we know that the sampling distribution is approximately normal. Any questions on that? Okay, whereas if you don't have that bigger than 5, basically you can't do anything. You cry because you can't get your work done. You want to publish something and you can't because your sample size is too small. And I want to let you know, and by the way, this is a an offer I make to all of you, is that if any of you ever need help, say when you're a graduate student writing your master's thesis and need help with stats, you're welcome to come get help with me and I'll help you out. Okay. But if you have a sample size that's too small, I'm going to be honest, even if it's going to make you cry. And I'm going to tell you, you need to survey more people because you really didn't survey enough for your dissertation. Does that make sense? So I'm always honest, even if you leave unhappy, don't be mad at me. I'm just going to tell you the truth. And by the way, if you're a student and you ask me a question, do you know how much I charge you? If you're not my student anymore,
Free.
it's free. But if you have a business and you're doing it for your business, do you know how much do you think you have to pay me? Any guess?
Percentage.
No, here's the answer. Nothing. But there's a big but. But I'm going to ask you to donate to student scholarships at our college. So, and that happens a lot, by the way. We've had a lot of scholarships based on the work I've helped out people, businesses. So I'll do that as a consultant. And then instead of paying me, you give money to a scholarship. Sound fair? So that's an offer I make forever. Well, until as long as I live. And so that's just a note, that it's a forever standing policy of mine. Okay. And this happens. And unfortunately, some people come to me and their sample size is too small. And then I have to tell them, sorry, you don't have anything useful and meaningful. You need to go back and get more people. Got it? Okay. And again,
A quick question. So does the NP and NQ needs to be over 5?
Yep.
Would it ever be like when NP is over 5 and not NQ with that?
So if NP is over 5 and NQ is not over 5, you still need to get more people. You need both of them to be over 5.
Okay, thank you.
If either of them is under 5, you're screwed, or 5 and under. Yeah, you're screwed. So they both have to be over 5 or you can't do this. Got it? Okay. And there are actually some textbooks that use 10 instead of 5. So 5 is like ultra minimal, just to let you know. Okay, so we've got it. We are over 5. We want a confidence interval. Guess what I need to do next? What do we usually do at this point?
Use the calculator.
Exactly. We need to go to the calculator. So let's go to our calculator. And I want to mention something since we're at it, because someone asked me, it'd be nice to have a clear button on the calculator. That was one of the extra, the extra credit question on the test. So I didn't put a clear button, but let me show you the clear button. If you hit refresh on the screen, it clears it out. So just if you ever need to clear all the numbers, hit refresh and that clears all the numbers. Okay, we need more than that for what we're doing. But I wanted to mention that because someone asked that for the extra credit, and it was a good suggestion. And I want to let you all know that it's not needed if you know to hit the refresh button, which clears everything out. But instead, I need to go back to the calculator menu and tell me what number.
$12.
Yep, 12. Confidence interval for proportion. Okay, our N was 916. That was our sample size. Our X is going to take a little work. So the X is a number of people who said yes. Got it? How do we find the number of people who said yes? Let me go back to the information that we've got. Any suggestions on how we find the number of people who said yes? Because it's not like immediately shown here. But we can find it. So how do we find it? Do you remember what represents the number of yes answers? I don't see y'all jumping in.
63%?
Huh?
63% of yes.
Okay, 63% is the percentage of yes answers, but not the number of yes answers. We're going to use it, but we need more than that. Okay, I don't see y'all jumping in. NP is the number of yeses. It's 63% of 916. So I'm going to copy that. I'm going to pop it in the scientific calculator. I'll paste it in. And you always round to the nearest integer. You can't have 577.08 say yes. That's just not possible. So you round 577. And that's our number, 577. Okay. What do you think a good confidence level should be on this one? I don't know. Did I ask on this one? Yeah, come up with a 95%. So we're going to do 95% again. So 0.95. Political science is always 95%, by the way. I don't think I've ever seen anything else in political science. Again, in things like medicine, healthcare, you'll see different stuff. And hit calculate. That wasn't too hard, was it? Okay, and it gives us a lower bound. I'm going to round to the nearest percent. So that's 60% to 66%. Or 0.60 to 0.66. So our confidence interval, 0.60, comma, 0.66. Our margin of error is plus or minus 0.03, or 3%. Any questions on the margin of error or the confidence interval? By the way, notice 63%. If you add 3 to that, you get your 66%. So margin of error is how far you are from the middle. And the 63% is the middle. Okay, so we could say with 95% confidence, the population or the proportion of all Americans who approve of Biden's let's call it work is between 60% and 66%. So notice, by the way, this is way over the majority. There's no question the majority approve of Biden right now. Any questions at all on this example? Okay, just a note, if many groups of 916 Americans are surveyed, each group would result in its own confidence interval for the proportion of all Americans who approve of Biden work. And we could say that 95% of these confidence intervals will contain the true population mean of true population, proportion of all Americans who approve of Biden's work. Any questions on the first one, by the way, is to interpret the confidence interval. The second is to interpret the confidence level. So on an exam, for example, read the question. I will let you know. I will always ask you this first one, interpret the confidence interval. And I will sometimes ask you the second one. So for example, if the exam were to have 2 questions about confidence intervals, only one of them is going to ask the second, both will ask the first. Because the first is the most important. Any questions on this example? Any questions? Okay, have I lost anyone? It's hard for me to know. Everyone following? Okay, are you going to be able to write out sentences like this and come up with a confidence interval? Because that's important. So the most important thing is you practice so you can get this done. What I found is most people who do a lot of practice get these right. And those who don't practice, they're just way off. So to practice writing these out. Okay. And by the way, this week, when are you going to have to write things out like this?
In the discussion,
Yeah, discussion post. Take the discussion post assignments very seriously. Look at my example in the discussion post. Look at the example I just gave you and realize they're similar. Look at the template, make sure you can do it. Okay. It's not that hard, but it does take practice. Any questions at all on this example? Okay, this is used all the time. Okay, it's really easy to find, especially publications, research publications that talk about confidence intervals. Okay, sometimes they'll say they found that it was 63% plus or minus 3%. So sometimes they'll write it that way instead of 60 to 66. Sometimes they'll write 63 plus or minus 3, which is the same thing. So you'll see that also. All right, so here's the next question. And that is sample size for a mean. Okay. So let me read the example and then I'm going to talk about the calculation a little bit. So suppose you wanted to find a 95% confidence interval for the population mean hourly wage of nurses in California. Okay, based on a preliminary study, the standard deviation is assumed to be $12 an hour. If you want a margin of error of no more than 50 cents, how many nurses must you survey? Because the idea is, hey, if you're off in wages by 50 cents, it's probably not that big a deal. People aren't going to care that much. But if you're off by a couple bucks, maybe people care. Does that make sense? That's how you choose your margin of error. You decide, what do you think is going to make people feel comfortable? And the question is, how many nurses should you survey? Any questions on that? Okay, this is very different than asking how many nurses should you survey so that you can use the normal distribution. Nothing to do with that. This is about a margin of error. All right, so I'm going to remind you a few things. And that is the central limit theorem. Do you remember that the central limit theorem says that sigma sub x bar equals sigma over root n? Does that ring a bell? Last week? Okay, that was a biggie. So what we can do is we can say that the margin of error is equal to z times sigma sub x bar. Okay, and the idea is that comes from the normal distribution idea. So Z is whatever that Z represents for your confidence interval. But sigma sub x bar is sigma over root n. So that means E is equal to sigma over root n, Z sigma over root n. So then a bit of algebra, multiply by root n, divide by E, take a square root of both sides, and you get n equals Z sigma over E quantity squared. Any questions on that? Okay, you've seen it in the video. I can get in trouble if I don't show you this. And I got in a little bit of trouble on something I did. I've never had a student be upset about me, but I've had other instructors be upset. And you know what that was? Other statistics instructors from especially other colleges, actually. And you'll see why students don't get upset, because I made it too easy. So all of these formulas and equations, it turns out I needed to show it to you so I can say I showed it to you, but that's not how we're going to do it. We're going to use a calculator. Okay. So let's go to our calculator. And let's go back to the calculator menu. Tell me what you think we're going to need. Which number?
Number 9.
Okay, number 9 is a confidence interval. We're actually not asked for a confidence interval. So it's not number 9 because we don't, let me read the question again. The question is, how many nurses must you survey? It is not find the confidence interval. In fact, we don't have enough information to find the confidence interval. It's how many nurses must you survey? So let's go back, see if you can tell me.
11.
It's 11. So how many nurses must you survey is the same thing as what sample size do we need to have? And notice that the survey question is how much do you make an hour? And the answer to that might be, I make $95 an hour. And it's a number, not a yes, no. Very important. So that's why it's a mean and not a proportion. So I click on number 11. And our sigma was $12 an hour. So our sigma is 12. What was E?
$0.50, 0.50.
Yep, 0.50. Okay, because that's our margin of error. 0.5 is fine enough. You don't need this extra 0. Okay, what's CL?
The 95% or 0.95.
Yep, 0.95. And I hit calculate n. 2,213. So the answer is survey 2,213 nurses. Any questions on this? Okay, I do want to give you a warning, and that is at most other colleges everywhere, you need to put it into these formulas. And so if you talk to other people who've taken stats, they'll have used this. So if you're mad at me for making it too easy, I apologize. But do you agree that was pretty easy? Putting in 3 numbers and hit calculate. But I did have a couple faculty get mad at me from a few different colleges. And it's like, well, it is what it is. Any questions on this? Okay, the key on this is to read the question and know what it's asking. And the key is it's a how many must you survey? How many must you survey? That's always sample size, which is different than estimate the wage. Estimate the wage is a confidence interval. Does that make sense? Okay, so there's an example, and they all kind of look the same when you're doing a how many must you survey when it's a mean. Things change a little bit if you're doing proportions. So we can also decide on the sample size needed for a confidence interval for a population proportion. Okay, one thing to note, by the way, is there is no standard deviation to even talk about for a yes/no question. So that's not even part of it. Any questions on that? But sometimes you have a preliminary estimate for the population proportion. So for example, if you knew what it was last year and you're going to try it this year and find out, then you're going to use last year's as your preliminary estimate. Or maybe you know what it is in all of the United States and you want to find out what it is in your town. So then you're going to use all of the United States as your preliminary estimate. Any questions on that idea? So here's an example. Okay. Suppose you want to find a 99% confidence interval for the population proportion of cars in the United States that are electric vehicles, EVs. Okay. So you want a margin of error of no more than 3%. How many cars must you look at? Any questions on the question? Okay, and what I decided I'm not even going to do is do the whole formula thing. The book has it, so you're welcome to look at the book, but it's not a requirement. You're not going to be asked for it. But you do need to use a calculator. Any questions on the question? All right, so now I go to the calculator and I hit back to the calculator menu. See if you can tell me what number I'm going to go to.
13.
Yep, 13. So by the way, today's a big calculator day. Have you noticed? We're using a lot of these, right? We've got what, 9, 10, 11, 12, and 13 all from this chapter. So there's a lot of calculators to keep track of. Okay. Do we have an estimate for P? Do we have any idea what P is? What do you think? Based on the information we're given, do we have any idea what the proportion of electric vehicle cars are in the United States?
No.
No, we don't. So we do no estimate for P. What was our margin of error? What was E? Maybe I'll go back so you can read it.
0.03.
Yeah, 0.03, because it says we want a margin of error of no more than 3%. So that's 0.03. And then what was our confidence level?
99 or 0.99.
Yep, 0.99. And we hit calculate. And you have to look at 1,844. So the answer is look at 1,844 cars. Any questions on that? Okay, by the way, would that be a lot of work?
Yes.
Yeah, that would be a lot of work. Okay. Maybe if we had a preliminary estimate, we'll find out we don't need to look at as many. Okay, so it turns out preliminary estimates always can never make it higher, but usually make it lower, almost always. So let's take a look. So here's the next question. Okay, if you look at last year's data, 2.2% of all cars were EV, electric vehicles. How many cars will you look at for this 99% confidence interval? Kind of in the same situation, but now we looked at last year's and we knew it was 2.2%. What's changed according to the calculator?
Half estimate for P.
Yeah, now we have a preliminary estimate for P. So I'm going to click have estimate for P. And when you do that, you'll notice estimate for P box shows up. So I programmed that so that you only get it when you need it. Got it? What do I put in for P? Let me put this back in so you can see. What is our preliminary estimate as a decimal?
0.022.
Yeah, 0.022. So don't forget to move the decimal over 2 places always. So it's 0.022. Any questions on that? Now I hit calculate N. Did it change?
Yes.
Yeah, drastically. We're now looking at 159. So for part B is we only need to look at 159 cars. Okay, it turns out that if you're far from 50%, then it does reduce a lot the sample size you need. Okay, and if you're running a business and you need to do this, it's very important that you know, because you got to pay people to do these studies. And if you need a sample size of 1,844, that's going to be very costly to you. Whereas 159 will be a lot cheaper for your company. Does that make sense? So it makes a big difference having the preliminary estimate versus not having it for this particular example. Any questions on this idea? Any questions? Okay, I want to make a note about confidence intervals. So the first thing is, before you even did the study, if you know you're going to do this study and you know you want a 99% confidence interval, before you even do the study, then you know there's a 99% chance that your confidence interval is going to contain the true population mean. Okay, you could say that before you even did the study. Any questions on that? Okay, that's pretty important to note, that you don't need to have already even done the study to know your 99% chance. Another way of looking at it is, let's suppose you were in the business of doing studies. That was your job. And let's say every week you did another study, for someone. Okay. By the way, do you think I've ever been in that business? Think that's ever been my job?
Yes.
Yeah. And now, ready to be shocked?
Sure.
This happened, but that was before I had my first passionate kiss. Things were different in my generation. I worked for a company when I was 11 years old. Okay. And obviously I wasn't a statistician. I was an 11-year-old kid. But the funny thing is, one of my first jobs was collecting data for a market research company. And that market research company, if they did, if they used 95% confidence as their confidence level, then 95% of the confidence levels that they ended up doing for their clients will contain the population mean, and 5% won't. Does that make sense? Okay. So I was one of those guys on the phone. Okay. It doesn't happen anymore, but I was an 11-year-old kid and I was doing surveys on the phone for pay for a company. Again, things are different. Now I think that company would go to jail. But, but in those days, that's what happened. And that company, 95% of their intervals would contain the population mean. And that was good enough for the company, and that kept their reputation. And that's what it's all about. You know, a big part of it is reputation. And you got to decide, well, what percent do you want to be right so that you can keep your reputation? Any questions on that? Okay, so what haven't I done yet?
The secret word.
And here it is. The secret word is population, because you don't want to forget the word population when you are talking about the confidence interval, to say that the population mean is between these numbers, or the population proportion is between these numbers. So population is a very important word for this chapter. That's the main word. So that is about everything I had to say about confidence intervals. And I want to let you know, if I lose you, what can you do? Right? If you leave this lecture and you have no idea what you're just like kind of lost, what should you do?
Go to your office hours or ask questions on Q&A.
Yeah, go to office hours, ask questions at Q&A, or get help from Balio, our tutor, right? Is great. Read the book. Watch the other video. Remember, there's another video. Okay, and I've been making these new videos that have the new calculator, so they're current. I even have adjusted some of the percents that I had from the old ones so that they're actually, you know, current. So again, there are a lot of resources. So if you, especially if you didn't do as well as you'd like to on the exam, make sure you go to resources and practice. Okay, so the resources are, again, office hours, Braulio's tutor hours, the textbook, the other videos, and there are many short videos also. I mean, there's literally dozens of videos. Okay, so there's a lot of help for y'all if you ever don't understand something. And I want to emphasize that because you just took a test. So some of you are feeling you need a little extra help. And I understand, you know, everyone's different in terms of the amount of time it takes them to get it all, you know, in their brain. But given enough time, you should be able to make it. So I'm going to close this off and drop my recording.